Dispatch is nothing but method dispatch, method as function dispatch, generally method dispatch. So which method to invoke is what the dispatch is. When you call a method, when the application tries to execute a method, which method it has to invoke is the dispatch. Okay. There are two concepts. One is called static dispatch and the other one is called dynamic dispatch. Static dispatch means which method to invoke is decided at the compile time. That means when you compile your application, the compiler is well aware of which method to invoke. Compiler doesn't need to, I mean, compiler is aware of that. Your runtime doesn't need to really look for that. There is no lookup table or there is nothing. Directly when you say that area of a rectangle, it goes and directly execute the area of rectangle. The simple example, let's say I copy this application and I copy this application. I'm removing everything from here. So if you take a look at it, for now, don't consider I shape and I display. I just talk about rectangle and then square and all. Let's say I create a rectangle. R1 is equal. R1 is new rect. I give some values and then R1 dot area, R1 dot perimeter. Whether you can put it as a square and then you put it as a cuboid, whatever it is. If I got to put it as a square, let me put it A2, P2, S1, mu square, S1 dot area, S1 dot perimeter, area of square S1 is A2, which is called P2, perimeter of square. If you want to put cuboid, you can also put cuboid. If you really look at this particular application, the compiler is very well aware of which object to invoke. Okay, the compiler knows that R1 is a rectangle, so it got to invoke rectangle object. It got to invoke the method called rectangle, which is called area, perimeter, similarly square, and then perimeter. This particular thing is called a static dispatch. In polymorphism way of doing things, generally they call it as a compile time polymorphism. In Go way of things, there is no polymorphism, but this is just a method invocation. It's a static dispatch. Okay, statically the methods are dispatched, methods are executed, everything is decided by the compiler at compile time. You remember that everything is done by the compiler at compile time, which we call it as a static dispatch. Well, the second thing is, so you understand what is a static dispatch. Okay, if you really follow our previous, I mean, my previous video, you can understand this, right? Previous session, you can understand this. This we have done yesterday's session. Again, right now for static dispatch, don't consider the interface. Just talk about the type and then type method invocation. So everything is well aware to the compiler, which is called the static dispatch. Coming to the concept called dynamic dispatch, let us say that I create a interface. I create an interface called iShape, and then I give R1, okay, and then iShape dot area, which is called maybe A3 I give, and P3, which is called iShape dot perimeter. and I got to print area of, let's say how I print. I mean, even no need of this, directly I'm calling this. So if you look at this, this got to be the dynamic dispatch. Okay. How could it be dynamic dispatches? Area and perimeter, which area, which concrete object area and then which concrete object perimeter to be called is decided at runtime, because I shape at once it may have R1 or rectangle object, later on it may be having square object, later on it may be having cuboid, later on it might be having even any object that implements the interface. Because the interface contains method signatures and then any type that implements these particular methods we have mentioned in the interface, they implicitly satisfies that particular interface. That's what we discussed about interface concept. The same thing, let's say, if I simply change from R1 to S1, if you look at it, now I shape is gonna execute not the area of rectangle, but the area of square, not the area of perimeter, uh, perimeter of rectangle, but here the perimeter of square. This is called dynamic dispatch. Even the previous example, whatever we have done, it's a dynamic dispatch. Any method invocation is happening through interface, not directly on a concrete object, but through interface is called a, it's called a dynamic dispatch. Okay. What happens actually internally in Go? So it's a very important concept. Static dispatch and dynamic dispatch are not only confined to Go language. Static dispatch and dynamic dispatch are general concepts which are there for Go, C Sharp, Java, Rust, C++ is very important and all. But generally other programmers, the other programming language, particularly C Sharp and Java, we don't think too much about these dispatches. But what is the problem? What are the benefits of it? Dynamic dispatch is very flexible in terms of design aspect. You can go for dependency injection, you can go for any kind of an implementation with interfaces, but there would be little bit performance penalty at runtime. The reason is whenever when a method is called on an interface, the Go runtime has to determine which concrete method implementation it has to invoke. You know that because here it has to know line number 23, it has to know whether it has to make a call, which what concrete type method invocation it has to do. That means somewhere when your application is loaded, Go should know about it. That's where actually the concept comes, the ITable concept. Sometimes we call it as an interface definition table, some folks, but generally it is called ITable. Why ITable? Interface definition table, basically we can call it as ITable. Why ITable? The similar concept is there in C++ and Rust, probably I'm not very sure in Java, which is called vtable, which we call it as a virtual table. A similar concept is there through ITable. What ITable is? ITable is generally a data structure that maintains the lookup, that maintains some information. It maintains the type information and then the concrete data information. You know that what interface contains. Interface contains the type pointer and the data pointer. I repeatedly explain certain things. The reason is for you to understand from the beginning. Okay, so somehow it could be useful. So the ITable, whatever we are talking about. So when does an ITable is created? Here it creates one ITable for the rectangle. Here it creates another ITable for the square. ITables are created for each concrete type that is assigned to the interface. Okay. What does ITable contains? ITable contains the metadata about the interface and the concrete type. The metadata about the interface, iShape. What does iShape contains? iShape contains some methods, some method signatures. That is the metadata. And also, what does iShape contains? iShape contains the concrete type. What value? There is a data pointer and type pointer, right? Type is pointer and the data pointer. This is the metadata basically. This is the metadata of iShape. And then here it contains R1 object. Here with respect to line number 20 until line number 27, it contains an object called R1. So it contains the metadata about the interface and the concrete type, and also the pointers to the actual implementation of the concrete type. That means it it's not like iShape.area. It's how does it implement? It should know exactly the pointer of the actual implementation of the r1.area. That means when r1 is this particular pointer, exactly it should know that this is the pointer. This is the pointer means I'm just explaining r1.area. That r1.area pointer is invoked here. Why does it invoke r1.area pointer? The reason r1 means the new rectangle.area. The reason is the ITable contains the concrete type implementation of rectangle. Here it is r1. So what happened is when a method is called on an interface, first thing is go runtime goes and checks for the ITable. Is there any ITable with respect to R1 or rectangle? Each concrete type contains one ITable. So normally here it doesn't contain any ITable. Here it doesn't contain any ITable. But the moment the concrete type is assigned to a interface, an ITable is created. So here there are two ITables are created. One is for the rectangle and one is for the square. Let's say if I create another rectangle object R2, for example, iShape equal to R2, it doesn't create another table, it maintains the information in the same iTable. So iTables are created for the interface and the concrete type. That's what the metadata is. Metadata contains the method signatures of the interface, and then it contains the data pointer and type pointer. Is iTable contains even more than that. So when a method is called on an interface, go runtime looks for the ITable and it has to determine which exact correct method that implements this particular call, that to invoke the call, which method it has to call. What is the concrete type that it has to call upon? What concrete type that the interface holds? All the information is maintained in the ITable. So it goes to the pointer of that R1 and then immediately it executes a method. Here it goes to the pointer of S1 and then it executes a method. But what is the performance penalty that we would have? We would be having is the application will have has got is ITable caches some data because it has to maintain some runtime information. It has to maintain some information at runtime. So your application contains, your more RAM is used, more memory is consumed because your application contains additional runtime. Your application contains additional data at runtime in the form of ITable because ITable doesn't come as free. It gets loaded into the memory. It contains its own memory, like interface, right? That's what happens. So to summarize, we cannot see ITable, but because there is no construct that we can go and then see ITable, but we know that there is a data pointer and type pointer, and then generally for any interface, but ITable contains even little more additional information about the only what you can ask me, what is the difference between a normal interface and then uh, any and then here. If it is a normal any, it contains only data pointer and type pointer. Here also it contains data pointer and type pointer. The moment you see this contains again data pointer and type pointer, but ITable is not for the interface. Remember that. That's what I was telling. ITable is every concrete type contains one ITable. Rectangle contains one ITable here. Square contains one ITable here. That's the difference. However, the interface contains data pointer and type pointer based on where exactly which type it has got. It immediately goes and then get the data. Fine. So to summarize, ITable is a internal runtime mechanism which is used for the dynamic dispatch. So the ITable maps the interface type to the methods of the concrete type. Concrete type means rectangle, square. So what happened? This is because of this Go can support the runtime polymorphism or dynamic dispatch, which is flexible, reusable, and then you can design your application in such a way that it supports interfaces and etc. It is more of a design aspect as well as enabling dynamic dispatch. Okay, this is what about the concept dynamic and static dispatch. Okay, we were discussing about static and then dynamic dispatch. I hope you understand the concept what I am trying to say.